Hello, yeah, so my name is Jelmer Vernooij, and I'm going to talk today about importing new versions of Upstream projects into Debian packages. This is sort of a continuation of some work that I've been doing for a while, the last couple of years. Like last year at DebConf, I gave a talk about the Debian janitor, which is a project to make automatic changes to Debian packages that are maintained in Git repositories, and sort of making smaller incremental changes to those packages. And so, yeah, let's start it by taking a bit of a step back. So Linux distributions like Debian fulfill an important function in the free and open source software ecosystem. They're system integrators that take existing free and open source software projects and they adapt them where necessary to work well together. They also make it possible for users to install more software in an easy and consistent way, and with some degree of like quality control and review. And of course, you could sort of argue over how much review and quality control happens for some packages in Debian, but we at least have some minimal bar that you wouldn't find if you just picked a random package off of PyP. And we've seen in the last year that there's some packages out there that have malware in them, for example. So we have a minimal bar, and packages are at least reviewed for their license. There's the policy as well, so all packages at least comply with the must-fits of the policy. And we also have mechanisms to try and encourage more conformance to the policy. And Debian also makes a bunch of promises around things like security updates, for example, and transitions between versions and things like that. So there's some good reasons for using a distribution. And if you were installing software directly from the Upstream project, you wouldn't really be able to manage it for all of the software. Obviously, you would only be able to do it for a number of Upstream projects. And so what a lot of people end up doing is using a Linux distribution, and then on top of that, they run a bunch of different Upstream projects directly out of, say, Git, where they really need the latest version. Yeah, so the common complaint, obviously, with some of this is that it's a manual process to update Debian packages to new Upstream versions. You have to do a bunch of bookkeeping, and one of the consequences of this model is that distribution packages often lag behind Upstream releases. And that's especially true for distributions that have more tight integration and standardization, such as Debian. Distributions that are more opinionated and give you a more of a sort of seamless experience, but it also means there's more work involved. And often new Upstream code is only imported irregularly because it's a manual process. So both the updating of the package, but also making sure that it actually still works together well with the rest of the system. And so there are a bunch of people who basically want at least parts of their system to be more rolling. And yeah, maybe there are some things that we can do to do that. So yeah, how do you import a new Upstream release today? I'm being a little bit unfair here. This is basically like when I started contributing to Debian many years ago, what the process was like. So basically, you have to go to the Upstream homepage, you have to find the tarball and the signature, you have to verify that the tarball is the tarball you should be downloading, and it was signed by the right people. You then have to convert the tarball to a format that actually fits in with Debian source format. So that might mean converting it to a tarball if it was a zip file, for example, and make sure that it has the right naming and things like that. And you might have to filter out like non-DFSG files, for example. Then you look through the changes between the latest upstream that's currently packaged and the one that you're updating to. And you look at what changes there are. So that can sometimes be tedious, but it's also really useful because you'll find that the changes that actually need to be incorporated into the package, and things like new license being introduced, for example, new binaries being introduced that need to be installed, or maybe the description for the package needs to be updated. Maybe new dependencies have been introduced. Once you've done that, you can move the Debian directory over to the new Upstream source checkout, update the packaging, as well as other things. And once you've done that, you can build the package. Hopefully it builds. So maybe you have to go through a few iterations, then you test it by manually installing it, and then finally you can upload it. So as I said before, like, I realize this is a little bit unfair since we do now have a bunch of tools to make some parts of this process easier. But I'll talk about some of those now. So yeah, the ecosystem has moved on since like the early 2000s, or maybe even before then. And we've introduced more and more sort of tooling to make all of this easier for ourselves. So Git is now fairly ubiquitous. Most upstream projects use it. Most packages in Debian use it. There are still a bunch of exceptions out there that don't use any version control system at all, or that use a different version control system, but they're becoming sort of increasingly rare. As a version control geek, I'm a little bit sad that we have more of a monoculture now. But as somebody who touches a lot of packages in Debian and a lot of upstreams, it's actually really nice to be able to use just a single tool. And Git is a great tool. Where like back in 2009, for example, we had Debian packages in about half a dozen different systems. And we still have that today, but except for Git as a version, most of the other version control systems have like maybe half a dozen packages. And you can see that in the graphs, and we have a mechanism for discovering the Git repository that a package is versioned in. So there's a VCS Git header that is very widely used. So there's like fewer than 5,000 packages that don't use Git and don't declare it. And there are tools around this as well. So there's step checkout to find out where the package lives in Git. And there's a VCS watch service which regularly scans all of the repositories. And for example, the Debian janitor listens to VCS watch notifications to prioritize scheduling of packages that have recently changed. Then there is Debian Upstream Metadata. So this is a DEB12, which defines a format that's based on YAML that allows the maintainer to specify various bits of metadata about a package's upstream project. So for example, where does its documentation live? Where's the wiki? Where should you report bugs? But also, where is the upstream's version control system? There's a little bit of overlap between Debian Upstream Metadata and some of the other control fields. So for example, the homepage field might be better placed in Debian Upstream Metadata nowadays, but historically it's been in Debian control. And so DEB12 is still a draft, but it's been widely adopted. So there's like 10,000 packages or so that ship one of these files, and about 8,000 of them have the repository header set. So that's actually quite a lot if you consider that we have about 30,000 odd packages. And then there's also a tool that can, in many cases, generate a Debian Upstream metadata file for you if you have the upstream source code. So gets Upstream Metadata from the Upstream ontologist package, can look at some of the Upstream files, and for example, it'll find the Upstream repository URL, but it'll also find things like where the bugs live. So in many cases, you can just run that to generate the file, but you might have to sort of double check it. It scans about, I think, 24 different metadata files, including things like README. Then there's auto package test. So this is a standard for declaring how tests should be run against installed packages. And it's great for things like transitions. And about, I think, half the archive has auto package tests. And there's the CI system, obviously, which runs all of the tests somewhat regularly. So that allows you to actually be sure that when you make changes to a package, it's not completely broken. Like obviously, the auto package tests aren't fully covering all of the functionality, but it gives you a little bit more certainty than just I made some changes and it happened to build, which can still mean that like binaries get installed in the wrong directories, for example. And then finally, the adoption of DebHelper, and is in particular DH from DebHelper. So over the last couple of years, we've slowly been converging to DH, and that's really nice because being able to rely on a single build tool makes it really easy to write, or maybe not really easy, but at least easier to write code to update packaging when upstream changes require it. So we had 3 different systems roughly before. The other thing with both CDBS and old style DebHelper is that they were make files, and it's notoriously hard to machine edit make files because it's just really hard to modify them compared to, say, the DebHelper files that we have today. And then another thing is that with DH comes sort of the do what I mean style thing in DebHelper. So for a lot of packages, you don't have to add a lot of configuration. DebHelper and the various DebHelper tools will just figure out on their own what needs to be done. And that means that if they figure it out on their own, there's also no configuration to be updated when you import a new version, for example. So there's that. So if you combine all of those changes together, it actually becomes feasible to, without any human intervention, updates packaging to new upstream versions. And of course, this does require that all of the information that I mentioned earlier is available. It requires that the package is using modern DH. Ideally, that it's using auto package tests, that the version control system that's used is Git. So like, as you saw, like some of the packages aren't there yet, and we won't be able to do anything about them, but that's fine. Like if we can import new upstream releases or new upstream snapshots for some percentage of packages, that's already an improvement. So we're not trying to get to like the ability to do this for all packages, just for some fraction, and then we can gradually increase the number of packages for which we can do this. An auto package at least makes sure that when we do this, we don't end up with packages that are obviously broken, and we can add other validation as well. So one of the things I've been working on is a new tool called DebNewUpstream, which basically does all of this. And it's basically a wrapper script that attempts to automatically update a package to a new upstream version by default, it updates to a new release, or it can update to a new Git snapshot. So you just run it in a packaging repository, and it will attempt to do all of these things for you. And then it both updates the Git repository with the new Upstream version, and it also delivers a built set of binary packages. So how does it work? Here's a diagram. Basically, what we do is we follow the process that I was just talking about using some of these tools. So we use VCF Watch to figure out where the packaging repository or when the packaging repository changes. DebCheckout can clone it for us. When we look at either Debian Watch with UScan or Upstream Metadata, possibly together with Guess Upstream Metadata, to figure out where the upstream lives. And then we merge the new upstream into our local clone, possibly also the pristine tarball. We figure out what we need to do in order to update the packaging. And sometimes at this stage we have to abort because we just don't know what to do. For example, if the patches no longer apply and we can't just refresh them, then there's nothing we can do. Then we attempt to build the package. If that doesn't work, we inspect the build logs and we try to identify what sort of problems exist. Maybe there's some missing binaries, or sorry, some missing dependencies. If there are missing dependencies, we'll add those to the package. We'll try again, and we'll just repeat that until either the package builds or we encounter a problem that we don't have a resolution for. And then once we have the packages, we run auto package test. If that fails, then obviously we give up. If it succeeds, then we upload to the Janitor app repository and we push to a Git repository as well. And so if we do this across the archive, which is one of the things that the Janitor's been doing for the past year and a half, this is what happens. So for fresh releases, so importing the latest upstream release, where QA Watch thinks there's a new release, this is what happens. So in 35% of the cases, we're actually already at the latest release. In 20% of the cases, we managed to import a new release and also managed to build and pass auto package test. And 20% is about 2,200 packages. So that's pretty nice. 2,200 out of 30,000. And if you look at the build failures, it's for a variety of reasons. So sometimes this is due to being unable to import tarballs. A lot of it is due to patches or conflicts with upstreams. Then there's fresh snapshots, which is actually a lot better. So about 5,500 packages are successful and have successful imports of basically nightly snapshots. And then the problems are sort of similar, but you can also see that for about 20% of packages, we don't know where the upstream actually lives. And I realize I'm a little bit low on time, but yeah, so what's next? Obviously, we would like to have more metadata so that we can do this for more packages. And there's a lot of packages that aren't on Git yet. There's some that are still declared to be on Elliot. It would be great to fix those. And then there's a bunch of tooling that we can improve as well. And there's a bunch of sort of harder problems. Like merge conflicts are basically very hard to deal with. Transitions are quite tricky as well as dependencies on packages that aren't yet in Debian. So like you can imagine that a new upstream release introduces new dependencies that aren't in Debian. And then we have to sort of automatically create packages for them. I have some ideas around that, but yeah, that is also one of the causes for packages not being able to build. And then finally, how do you actually use these packages? So there's about 8,000 of them. If you go to the URL here, you can find instructions, or you can type them over now. But that you're gonna have to type really, really quickly. The packages are also in X repo soon, hopefully. And if you're a maintainer, yeah, please make sure you have the metadata files. You can also go to the generator page to see the status of your packages. And if you'd like to receive merge proposals or pull requests with validated upstream release merges, please have a look at the FAQ. And then finally, this is where you can find more information.